Where is EN? Not here yet. What's AFK? Stand for? Away from keyboard. Right, start our lesson. Our plan. Let me show you our plan. Now is week 6. Okay, week 6. And then we have week 7. So today, I will complete chapter 7. We have about 30 plus slides. So I will clear this chapter today. Together with the tutorial will be, of course, tutorial time tomorrow. And then this one is Tuesday. Okay, Tuesday and, Tuesday and Wednesday. After that, Thursday and Friday, we have a presentation, right? Assignment presentation, Thursday and Friday. So next week, final week, Tuesday, we will have the last chapter, chapter number 8. Okay, and then followed by the tutorial on a Wednesday, Thursday, and Friday will be the revision. So revision, we will discuss 2 sets of past year question. Am I missed out anything here? So this will be our plan this week and next week. Seems everything are in. Okay, tutorial setter, practical assignment setter, revision, last 2 lesson. So we will complete our syllabus next Thursday. Any question, our arrangement? No question. No question. So I can check your message. No question. Yeah, we plan nicely, so we will work accordingly. We have about 40 slides today. Please allow me to speed up a little bit so that we can finish our syllabus on time. Okay, this chapter you can refer. This chapter truly come from the reference book, software engineering reference book, main reference book. Yeah, truly come from main reference book. You might, if there's certain topic that you need to go further, there are a lot of example there. So today I'll briefly share with you what is this configuration management. Can we start now? Everybody ready? Ready? So what is configuration management here? It's a process. Yeah? It's a kind of a system engineering process to establish the consistency, consistency of products attribute throughout the life. The software systems are constantly changed during development of use. So when a system requirement change, we need to implement changes to the new version of a system as well. So let's say there are new version of a hardware or a system platform release, then we have to adapt our system to work with the new versions of a hardware or system platform. We need to manage. We need to manage the evolvement of the system so that it can be easily tracked Yeah, easy to, or else you'll be easily lost track of what changes and also the component version that have been incorporated into each system versions. If we don't have effective configuration management procedures, we may waste our efforts. Yeah, we may waste our effort to modify the wrong version of the system or wasting the time to do the adjustment. Or could it be deliver the wrong version of the system to customer as well? This configuration management is essential for the team project to control the changes made by different developer. Okay, that's the core, yeah? That's the core content. Let me repeat for you. Configuration management is essential, is important, is crucial to the team project to control changes, especially made by different developers. Because sometimes one developer, the same component might work from working together by different developers. The easy for one person to forget what changes has been made or has been done before. So when several developers are working at the same time on a software system, sometimes the developer themselves might forget what is the progress, and perhaps they're also working at another component. Yeah, so we need to do some configuration management so that every developers they can manage the changes that they have made to the system. Yeah, they can manage and also they understand what is the latest changes to the system. So next one, we look at the 4 activities here. Configuration management of a software system product involve these 4 activities: version management, system building, change management, and also release management. So what is the version management here? The slide very clear, yeah, very straightforward. Version management here, keep track of multiple version. That's a key term. So system building to create executable system. Change management, by change management here, keep track requests of changes. Release management, um, here also keep track, but is the system version that have been released to the customer use. That's what I call release management. So those are the keywords. You might highlight your notes. So this configuration management explanation is in the next slide. Slide number 6. So the development of the software product or custom software system has 3 distinct phases here. What are the 3 distinct phases here? Okay, first one, development, oops, development phase. Activities, oh, this one, sorry, activities is here. Okay, activities, diagram is here. So different phases, 3 different phases here: development phase, system testing, and also release phase. So development phase here, where the development team, development team responsible to manage the software configurations when there is a new functionality being added to the software. Okay, clear, straightforward this sentence. So second, in development phase also, the development team might also decide if there is any changes Yeah, functionality. New functionality means if any changes has to be made, has to be added, need to be added to the system or software. System testing phase here, at this stage, shall have no additional functionality added to the system. Okay, no more new functionality added. So the changes made at this stage, usually like performance improvement, fix bugs, or security vulnerability repairs. They may be involve some customer. Yeah, they may be involve some customer as a beta tester during this phase. How about release phase here? So this stage, software release to the customer. So after the release has been distributed, the customer may submit the report or change request if any. Yeah, after the release, customer may request change if any. So the new version of the release system may be developed to repair if any bugs are submitted, report submitted by customer, or repair any vulnerability, as well include any new features, yeah, new features that suggested by the customer. We look at a multi-version system. For large system, yeah, for large system, there are always several versions of the system at different stages of development. So this one applicable to large system. What is this about? We look at the diagram next slide here. Okay, 1 minute, go through this diagram. Take a look. What is this about? Development, version, pre-release, releases. Okay, 1 minute here. Right, in this figure, we look at the version 1.5. So here shows that the figure shows the situation where three versions of the system are being developed. So version 1, version 2, and also version 3. So version 1.5 of the system has been developed. So in this case, this version has been developed to repair any bugs, yeah? And also improve performance of the first release of the system, version number 1. So this will going to be the basis to the second version or second system release. So version 2.4 here being tested, yeah, being tested with a view become a release 2.0. No new feature shall be added at this stage. Version number 3 is development system, where the new features being added responded to the request from the customer, or maybe the development team also. So eventually we'll release 3.0. So this different version have many common components. Each component, they will be unique. They will be unique for different version. Each component unique from version 1 compared to version 2 and also version 3. So the configuration management. The configuration management, you keep track of the components that are part from each version and also might include them into the system build. We look at some of the common terminologies in configuration management. So there are 2 slides here. So what means by a baseline? Collections of components that make up a system. Branching, new code line from version in existing code line. So please go through these terms as well next slides. What means by merging, release, repository, this one you need to know. Because later on we have many rounds, you meet this term. What is this? A repository mean? Share database. Yeah, keyword is here. Share database of a version of a software component, meta information about the changes of the component. So keyword is this, share database. System building, creation of executable system version. Yeah, these two. Take notes. Next one, we look at the version management. What means by version management? VVM. Keeping track, all those keywords I did highlighted in red, so that you can focus those keywords. So version management, keep track of different version. Also involve ensuring the changes especially made by different developers do not interfere each other. So this what core content for version management. So different version by different developer. So version management will ensure the changes done by different developers will not be interfere. Yeah, will not be interfere the result, the latest updated changes by each and another. So therefore, version management can be thought of the process of managing code line and baseline. So managing is a keyword here. So what is a code line and a baseline? Code line, baseline. Code line, different version. Yeah. Baseline, component in the version. Next slide also did explain in further what is a code line and also baseline. So the one, look at the one highlighted in red, code line, sequence of version of a source code, usually apply to component, which is with their different version. How about baseline? Definitions of a specific system. So specifies the component version that are included in a system, including specifications of library use, configuration use. So this is baseline, this is code line. You look at the next slide again. Yeah, explain in further what is baseline. So what's the keyword here? Let's look at the slide. Okay, why this baseline is important? Because you look at the second paragraph here. Baseline important because you often have to, let me highlight, recreate a specific versions of a complete system. Look at the example. So product line may be instantiated so that there are individual system version for different customer. Okay, different customer. So in this case, we have to recreate the version delivered to the specific customer. Yeah, the customer report in a system that have been repaired. So provide example here. Yeah, highlight those keywords. So different customer might have their own, was that different versions initiated for different customer. So let's look at the differences here, code line and also baseline. Next slide, look at the diagram here. Yeah, code line, baseline, this is so what's different between these two? We can see so code line A, B, C, libraries, external component, baseline, version 1 and version 2. So this figure, we can see that different baseline, okay, different baseline here uses different versions, of the component for each code line. So the one that's shaded in the box here represent the component in the baseline where we're integrated. They're actually reference component from the code line, right? A, okay, B12, C11. There's reference there. So the main line here is a sequence of the system version that developed from the baseline. So how about next one? Version control system. Some they call it version management system. So same, huh? Version control system, or some reference they call it version management system. So version control or version management system identify, store, keyword is here, control access different version of the component. That's why they call it version control. Actually, we can guess. We can guess what it does it mean by the name itself, version control. Yeah, control different versions of a component. So what is a centralized system here? Single master repository, which maintain all version, centralized system. I think this term is not new, not new to all of you. Distributed system, multiple version, but exists at the same time. Yeah, please highlight keywords, centralized system and distributed system. Right, next slide here, we look at the key features of version control system. Do we have, okay, the explanation not in, but I will briefly share with you what is these 5 features here. So this first feature, version and release identification, here referring to every component. Yeah, every component we're going to assign a unique identifier. So every component will assign a unique identifier. So the unique identifier that assigned will allow different version of the same component to be managed, yeah, based on the identifier. The second one, change history recording. The version management system will keep track, yeah, or the version control system will keep track the changes that have been made. Create the new version. Let me repeat. The version control system will keep track, keep record of all the changes that have been made. That's why they call it history recording. Yeah, and then a new versions of a component will be created from the earlier version. Means once they have new changes, that means they're going to have a new version. So all the previous version will be recorded. The third one, independent development. So different developers may be working uh, the same component at the same time. Now, let me repeat. For independent development here means, let's say different developers, they might work at the same component at the same time. So the version control system, version control system will keep track of the component that have been done editing. We use the word check out editing, mean they already done the edition, and then to ensure that each changes made by the component by different developer might not interfere each other, might not overlap each other. How about project support here? The fourth feature for our version control system, project support. The version control system might support the development of several projects, so all which might share their component. All the check-in, check-out of the files that associated with the project will also be updated each and another. Storage management here. We look at the last key feature, storage management. So instead of maintaining separate copies of all versions from different developer, the version control system may store, they might store in specific version rather than maintaining multiple copies from different developer. We have a diagram later to show you what does mean by this storage management. So the specific version with differentiation will be applied and automatically will be recreated to the master version. Storage management. We look at the next slide here. Public repository and also private workspaces. 1 minute, go through the slide. 1 minute, look at the 4 point here. Look at the one that highlighted in red. Those are the word that we use many times later on. The version control system, or sometimes call it version management system, use the concept of project repository or public repository and also private workspace. So project repository here maintain master versions. So this is keyword, maintain master versions of all components. So when modifying component, developer will check out. Okay, keyword. Check out here means we'll copy from the public repository into their private workspace. Okay, something like this. We check out. Maybe later I'll explain this diagram. You understand the definition, the meaning of a checkout and check-in. So checkout means the time that modifying the component, the developer might copy the component from the public repository into their private workspace. That is a checkout. How about check-in? When they have finished the changes, the change component will return. Return or check in to the public repository. So please highlight these two, very important. This one, this part. Okay, highlight the content there. Check out and also check in. Check out, copy from public repository to private workspace for changes. So after change might return. Return here we use check in. I mean get back to the public repository. Okay, have you done? Most software development is a team activity. Cannot be done by individual. Yeah, but team involve team members. So if let's say several team members have often work on the same component at the same time, sometimes we want to avoid any interference or overlapping. For example, if let's say, okay, I give you a simple example. Let's say we have a two-person here, Alice and also Bob. Yeah, Alice and also Bob. So if let's say Alice make changes to the system, let me write it down here. Let's say we have Alice and also Bob. Yeah, two-person. So if let's say Alice makes some changes to the system, which is involve changing component A, B, and also C. And at the same time, Bob also working on the changes X, Y, and also C. So now both Alice and also Bob, they are doing changes. Yeah, they are changing C. Yeah, they are changing C at the same time. So it's important to avoid the situation where the changes interfere with each other, Alice and also Bob. Such as Bob changes to C will not override by Alice, or Alice changes will not override Bob. So how? Later on, I'll show you in the diagram. So to support this independent development without the interference, so all version control system might use the concept of project repository. This is what they call. So the version control system might use this concept, project repository, and also private workspace to solve the issue. Yeah, the definition is here. So project repository might maintain master version of all component. Let me go to next one. In the centralized system, developer might check out the component or the directories of component from the project repository private into their private workspace, and also work on the copies in their private workspace. So when the changes are complete, they will check in the component back to the repository. So this might create a new versions that might be shared to each other. So we look at this slide, slide number 18, centralized version control. Okay, if several people working on the component at the same time, so each check in out from the repository. If a component has been checked out, the version control system warn other user wanting to check out the component that has been checked out by someone else. We look at the diagram here. Okay, 1 minute to you. Oh, take a look all those rectangle name labels. Done. Alice is here. This is a private workspace. Bob is here. Yeah, Alice is here. Bob. So check out, check in, check out, check in. Version management system or version control system. Okay, let's look at what means by this diagram. So now Alice, check out the version here. Check out. Can you see my pointer? Can, huh? So this one, check out. So Alice, check out version A 1.0, B 1.0, and also C 1.0. So she has worked on this version and has created a new version, A 1.1. Okay, here B 1.1 and also C 1.1. So she checks this new version into repository. So for Bob's case, Bob's check out these three, yeah, X 1.0, Y 1.0, and also C 1.0. So he creates new versions of this component, X 1.1, Y 1.1, C 1.1, and then check them back into the repository. So however, Alice has already created a new version of C, while Bob has been working on it. So his check-in. So Bob's check-in, therefore, will create another version called C 1.2. So this is by Alice C 1.1. So when Bob's check-in, will create another version called C 1.1 at 1.2. So there's no interference here. So the Alice changes are not overwritten or will not override by Bob. This one by Alice, this one by Bob. So this solves the problem if two or more people working on the same component at the same time. So this system version management system will ensure when the modified component are checked in, the different version will going to be assigned. And different version going to be assigned different version identifier. They call this one as identifier. And also store them, different identifier, also at the same time, store them separately. So that the changes made by more than 2% will not be interfere each other. So their result assign different identifier and store separately. So this is what the concept of version management system. Any question up to here? Yes, no? Everybody fall asleep already? No at the moment, Wong Yap Hao say. No at the moment, but later not sure yet. So far, no question. So far, no question. Let me look at how many diagrams. A lot of diagrams this chapter. Maybe I go few more slides before we take a short break. I know some of you maybe haven't breakfast yet. So we look at the distributed version control. Look at those keywords. Master, this for distributed version control. Master repository is created on a server that maintains the code produced by the development team. So instead of simply checking out the files that they need, a developer will create a clone. Yeah, keyword is here. Clone of the project repository that is downloaded and installed on his or her computer. So developer work on the files required and then will maintain new versions on their private repository on their own computer. So when they have done changes, when they have finished making changes, yeah, the changes updated, yeah, they will updated their private server repository. So they might push the changes to the project repository or tell the integration management that change versions are available. We look at the diagram here. So cloning, if you understand this meaning, then should be fine. So in this figure, both Alice and also Bob have cloned the project repository and have updated their file. Yeah, cloned the project repository and updated their file. They have not yet pushed this back to the project repository at the moment. Unless, yeah, unless this part. So when changes done, they commit changes, they'll update, yeah, they'll update their private server repository, or they may push the changes back to the project repository. Yeah, they may push it back to the project repository if any changes, or they might inform the integration manager that they have a new changes version or new changes version is available. So either one. What's the benefits here? Look at the slide. What are the benefits here? First, distributed version control provide backup. Yeah, because you clone the component. Second, allow offline working so that developers can commit changes if they do not have network connection. Since, yeah, since the file has been downloaded and installed on their computer, so they can do it offline. So this is a second benefits. The developers can compile and test the entire system on their local machine and test the changes that they have made. So this is a benefits of distributed version control. Okay, a lot of concept this chapter. Next one is about the open source development. Let me see any keyword here. This one, distributed version control essential for open source development, where several people may be working simultaneously on the same system without any central coordinations. Yeah, it is up to the open source system person in charge to decide when to pull the changes to the system. What is this example shown? We got one new member here, Charlie. Alice, Bob, and also Charlie. So what is this? One. So definitive, project repository, public repository, and also public repository. So what is it? 1, 2, 3, 4. For number one, yeah, for number one. So Charlie is in this case, Charlie is the integration manager for the open source system. So Alice and Bob, they both work independently on the system development, and also both of them clone the project repository. Yeah, both of them, Alice and also Bob, clone the definitive project repository. So both Alice and also Bob maintain the public repository on a server which can be accessed by Charlie. Okay, you see the line, number 3 here. Yeah, can be accessed by Charlie, the one here, this arrow. So when they have made the tested change, they'll push the change version from their private repository to their personal public repository and tell Charlie that the the updated repositories are available, and this can be accessed by Charlie. After that, Charlie might pull the updated latest repositories into his own private repository for testing. Once he is satisfied with the changes and the changes are acceptable, he will update the project repository. So this is the sequence or the process. All right, up to here. Let me look at the next one is branching and merging. Okay, we will continue this one after a break. 10 o'clock, let's have a 15 minutes break. Yeah, come back after 15 minutes. Let's come back to the class. Everybody here? Everyone here? Only add student here. Others not here yet. Wong Yapao, Elvin, Solomon, Elvin already. 12. So Lim and Shak absent, right? Let me double check. Shak is here. Lim, so Lim absent. 1, 2, 3, 4, 5, 6. Yeah, one student absent today. Let's continue our slide here. Branching and merging. We have about 15 slides more. Look at the slide here. Where's the keyword for this? Rather than linear sequence, there may be several independent sequences. This is normal in the system development where different developers work independently on different versions of source code and change it in different way. So in general, in general, it's recommended when working on a system that a new branch should be created so that the changes will not or do not accidentally interfere or break the working system. So we look at here, at some stage, it may be necessary to merge the branches to create a new version that include all changes. If the changes may involve different parts, the component version may be merged automatically. So it's about branching and merging. So we look at the figure, next slide. So from here, we can see that version component version 2.1 to 2.1.2 and also version 2.3 are merged. Yeah, merged to create version 2.4. We understand that the changes made by different developers sometimes overlap. So, and also the changes may be by different developers sometimes could be incompatible, interfere each other. So in this case, the developer has to check. Yeah, developer has to check all those interfere component and also make changes to the component to resolve the problem of incompatibility between the different versions. So split up different branches and some need to be merged. How about storage management here? This is one of the most important functions. When the time version control system develop, right? This storage management is one of the important functions here because this space very expensive. And it's important to minimize the disk space used by different copies of component. Instead of keeping the complete version, the system shall only store the differences. Yeah, look at the point number 3 here. So instead of keeping the complete version. The system shall store the differences only rather than the whole system. These differences we call deltas. How about system building here? System building in version management is a process to correct. So mainly concept, yeah, in this chapter. System building here means process of creating a complete executable system. This definition is listed in the table just now, if you remember. Here, this one, the terminologies. Okay, come from here also. Configuration, management, terminologies. Get back to here. So system building is a process of creating complete executable system by compiling and linking the system component. Also included external libraries and configuration files. So this system building might involve assembly a large amount of information about the software and also the operating environment. Okay, in short, in general, this system building here means assembly large amounts of information about the system and also the operating environment. So we look at the platform here. There are three: build system platform, development system, build server, and also target environment. So development system include development tools, build server used to build the executable version of the system, target environment where is the platform the system execute. Concept, this slide, next one. We look at the diagram here. So there are different system platforms involved here. Do we have the explanation here? Don't have, so you have to listen. So development system, one, and then build server. Another one is the target environment. Okay, here the explanation is here. So the diagram is here. You can refer both at the same time. The development system here include the tools like the compiler and the source code editor. So the developer might check out. Okay, check out is here. Developer might check out the code from the version control system or version management system into their private workspace before making changes to the system. For the build server, used to build the executable version of the server. So all of the system developer might check in the codes to the version control system on the build server for the system building. How about target system or target environment here? This is a platform which the system will execute. So same types of a computer that is used for development and the build system. Let's say for large system, the target environment may include the database and other applications that cannot be installed on the development machine. So it means that in that situation will not be possible to build and test a system on the development computer and or on the build server. So this one is meant for the large system. How about system building Oh, just now I saw one message from Pharaoh, isn't it? Whether exam got a diagram or not, I'm not sure. I'm not sure. But we have two past year question. We have two past year samples of past year question. You look at the format there in the Google Classroom. So this one, system building involve assembly a large amount of information about the software and also the operating environment. So from the figure, we can look at the here showing the use of automated tools, automatic build system tools to correct the build system. So from here we can see that we can notice not just need the source codes, not only the source code file involved in the build system, but also with other external files like library, data files, configuration files, right? All these are involved. So we might have to specify the versions of a compiler and also other software tools that to be used in the build system. So all are working together. How about the functionality here? 1, 2, 3, 4, 5, 6, 7 functionality. Let me explain briefly. Let me explain briefly each one. So the first functionality here, build script generation. So the build system should analyze a program that is being built and also identify the dependent components, and also shall be managed to automatically the generate configuration files. Version management system or version control system integration here means the build system should check out the required versions of the component from the version control system. How about the third functionality, minimize recompilation? Here means the build system should work out what source code need to be recompiled. What source code need to be recompiled and set up the compilation if required. How about the fourth functionality, executable system creation here? The build system will link the compile object code to other required files like libraries or configuration files to create the executable system. How about test automation here? So some build system can automatically run the automated tests using the test automation tools. Reporting here, the build system should able to provide the report about the success or the failure of the testing. How about documentation generation? So this one is about generate the release notes about the build system. So we have a example. So this example, I leave it to you. We look at change management. Okay, 1 minute, go through the slide, read through what is this change management. Yeah, we can guess from the name, change management, manage changes. So this organization might need to adapt changes, may need to, may need to adapt with the changes environment. Requirement change during lifetime system and then adapt to changes in the environment. So the change management here is to ensure that the evolutions of the system is controlled. Do we have a keyword here? So that the evolution is under control, and the most important is the cost effective changes has to be prioritized. Yeah, give priority to those urgent and also cost effective changes. So change management is a process of analyzing the costs and also benefits to the proposed changes. So those changes that can provide, bring more benefits to the company in terms of cost and schedule or time or quality, all those will be prioritized. So we look at the next figure here. Change management process, CR means change request. This figure showing change management, a bit complicated, isn't it? This figure showing change management process about the main change management activity. Change request, here customer support, check change request, valid, invalid, implementation analysis, impact, what is the impact, what is the benefits, modify, and then test. This is a process. So many variants of this process is used depending on whether the software is a custom system or whether it is a off-the-shelf product. Off-the-shelf here means those product that's available immediately and does not need any specialized or particular purposes. So the variant of the process also depends on the size of the company, yeah, and also depends on what type of changes. Small company might use less formal process, yeah. Small company might use less formal process compared to large company. However, all change management process should include the same checking, a same process including the uh, the checking, the costing, and also the testing, and then whether approve or not approve the changes. Next one, we have the change request form. Okay, project, who is a requester, change, analyzer, component affected, associated component, student database. Change priority, medium or high, estimated effort, and so on. This sample, yeah, this change request form sample refer to refer to large complex system project. That's why more detail. This form shall always focus on the changes required. Yeah, this part. And less emphasize on the implementation issue. Should be more emphasized on what changes are required. The After that, the system developer might decide how to implement the changes and estimate the time required to complete the change implementation. All right. So this, if the change request form in electronic format, the information will share between all the groups who are involved in the change management. After that, the change request will process, and if any added information, they will add it into the form. Yeah, record the decision made from each stage of the process. So from here we can see those are important information regarding the changes. So the degree of formality, you may also ask, how formal, how much detail should we need to put it down in the form? It depends. Yeah, the degree of formality is depends on the type of organizations and also the size of the organization and also the system itself. That's why there are no one size fit all concept. Depends on the type and the size of the organization as well the developing system. Factors. Factors that influence the decision on whether or not to implement the change. So there are 1, 2, 3, 4, 5 factors here. So factor number 1, we'll look at the consequences if not making the change. So we have to consider what will happen if we do not want to implement the changes. Will the changes associated with the system failure? Yeah. If the system fail, will it cause the system crash? Will it be serious? Is it important to fix the problem quickly? Or the changes, would it be a high priority, low or medium priority? What are the consequences? If you're not making changes, you have to consider in further. Yeah. Second, second factor, we look at what's the benefits of the changes. Will the change benefit to particular user or many user of the system, or maybe only benefit to the person who are propose the changes? So you have to do some you have to list out, outline in further detail who will benefits when changes done. How about the third factor, the number of users affected by the change? Will it be affected few users? Will it be affected many users, different stakeholders? You might assign the priority accordingly as well. The fourth factor, the cost of making changes. Will it take a lot of time or cost to implement? If no, then maybe at the moment the change can be rejected. Oh, sorry. If yes, if take a lot of time and also cost to implement, then may reject it. If not much cost, additional cost have to spend up, and then the time also still within the schedule time, may consider. The product release cycle, if, okay, this one interesting. If let's say the new version of the software has just been released to the customer, yeah, if the new version has just released to the customer, then the implementation of the changes could be delayed a little bit. Okay, until the next plan release. Next slide here, derivation history. So as the development team changes software component, they should maintain the records of changes. So all these are common, right? They should maintain a record of changes for each component. So this sometimes they call it derivation history of a component. So a good way to keep the derivation history is standardize a comment. Yeah, standardize a comment at the beginning of the component source codes. Next one, we are finishing our chapter. It's about release management. What is this about? What's definition of system release again? The version. Yeah, system release is a version of the software system that distributed to customer. So for mass market software, usually possible to identify two types of release, major release or minor release. Major release means deliver new functionality. Minor release, repair bugs, fix customer problem that have been reported. Okay, that major different. Minor release and major release. Okay, for custom software or software product line, releases of system may have to be produced for each customer, and individual customer may be running several release of system at a time. Okay, next one. Release component include configuration files, data files, installation program, documentations, and also publicity. So 5 components here. Preparing and distribution a system release actually for mass market product is an expensive process. So in addition to the technical works that involve in creating the release distribution, the advertisement and publicity also have to prepare, or else nobody knows that what products that you are releasing. Yeah, even though you have a good product, if without advertisement, marketing, then all those effortless. So in this case, marketing strategy also important. Marketing strategy is important to you have to design a good strategy to convince potential customer to buy the new release of the system. Of course, need to careful thought by all the team. Careful thought in terms not only marketing strategy, but the timing also important. If the release too frequent, okay, if the release too frequent or required hardware upgrade, customer sometimes may not move to new release, especially if they need to pay for the new release and the release time just not too far from the previous release, then they might not consider the new release. So you have to thought of the strategy and also the timing. So factors influencing system release planning. Various technical and organization factors we should take to the account when deciding when to release a new version of software products. So you might consider these 4 main factors. Yeah, competition, marketing requirement, platform changes, and also technical quality of the system. That's all for chapter number 7. So we already covered all this. Okay, this is a theory content. You can read through. If you need further explanation, please look for our main reference from Ian Somerville. That's all from me today. So what's your homework today? After done, please look at the tutorial question. There's only few questions for tomorrow. Tutorial 7. Okay, software configuration management. Describe what is branching and merging, how these two terms are related, between code line and baseline. Question number 2, 2 factors you should consider when releasing a new version software. We just covered this. Question number 3, one of the change management activity is to improve change requests from stakeholder. Discuss the factor that influence the decision on whether the change request shall be improved. All these are in the lecture notes. Please further explain your answer. Yeah, if you want to get a good mark, please further explain in more detail. That's all from me today. Thank you. Bye-bye. See you tomorrow.
Okay, Miss. Thank you.